So here we go on our second page. Quadrilateral RSTU has vertices of those four ordered pairs. Which statement about quadrilateral RSTU is true? So we can graph it here to maybe see, maybe have us help. And we've got 1, 3, which is R, 4, 1, here's S, 1, negative 3, T, and U is negative 2, negative 1. So R, S, T, U. And our first one says, since the diagonals of quadrilateral RSTU are not congruent, it is not a rectangle. So let's start by finding our diagonals in this problem. I'll do RT first because we can just simply count. Vertical line this time. And we have 1, 2, 3, 4, 5, 6. So RT has a length of 6. And we have to do a little bit more work on US here. But we'll draw our triangle, and we'll use the Pythagorean theorem. And we've got a distance of 2 here. And 1, 2, 3, 4, 5, 6 on that one. And if we squeeze it in here, 2 squared plus 6 squared equals c squared, which is 4 plus 36 equals c squared. And 4 plus 36 is 40 equals c squared. And if we take the square root of both sides, we get c equals the square root of 40. Well, the square root of 40, just in case we need it, is second square root of 40 is 6.3. So what we do know is that the diagonals are not congruent. If we look down below, it says, since the diagonals of the quadrilateral are congruent, it is a rectangle. Well, they're not congruent. So A is definitely true. Let's just check real quick about the adjacent sides have equal slopes. And when we look at the slope here, we've got 2, and then 1, 2, 3, 4, and then the adjacent sides of quadrilateral RST, you have equal slopes, but we don't want equal slopes actually. We don't even need that. What do we need for, since they have equal slopes, it is not a rectangle. Well, even still, when we look at that, they do not have equal slopes because we're going to rise 4 and 1, 2, 3, 4. I think rise 4 and run 4. We don't have equal slopes. So I think that we are going to stick with the letter A here. We lucked out on that first one. But even if they had equal slopes, well, if they had equal slopes, it's true, it wouldn't be a rectangle. We need slopes that are opposite reciprocals for them to be a rectangle. But as we finish here, we've got a little bit of algebra to work with on these last 3 examples. And it says quadrilateral PQRS is a rectangle. And what we know is that PR is 4V minus 98. So the whole length here is 4V minus 98, this length. And QS is equals 82. And if you remember from the front side, what we said about diagonals of rectangles is diagonals of rectangles are congruent. So what we can do is we can set 4V minus 98 equal to V plus 82. And we can solve. Solve it the way your Algebra 1 teacher taught you. Subtract V from both sides. And we have 3V minus 98 equals 82. Add 98 to both sides. And we have 3v equals 180. And then when we divide both sides by 3, we'll get our value of v, which is 60. Quadrilateral. STUV is a rectangle. SW is 2p. And VW is p plus 53. Can't write on that one. Oh, I erased everything, yay. What is the value of p? Well, the thing is, a rectangle is a parallelogram. And in a parallelogram, diagonals bisect each other. So when we set this up, what we can say is 2p equals p plus 53. And again, when we solve it the way your Algebra 1 teacher taught you. But our goal here is to find p. So we subtracted p from both sides, and p is 53. And simplify. We've got a lot of different angles to look at. Something that the OST might like to do. But knowing that diagonals bisect each other, one of the things that we know right away is that this length and that length there are congruent. So we can find angle 1. In fact, we've got a bunch of angles here. We've got angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 that we need to find. But the nice thing is, if we've got an isosceles triangle there, what we know is that this angle and that angle are the same. So we can find both of those. And what we know in a triangle is that there's 180 degrees. So if we take 180 degrees minus 126, we get 54. And then when we divide by 2, because these angles, we've got 54 degrees left, we can take 54, divide by 2, equals 27. We know that angle 1 is 27, and angle 2 is also 27. Another angle that we know, going out of order here, is that 126 here is vertical to angle 5, which means that angle 5 is 126 degrees. To figure out angle 4, we can use the fact that these two angles are supplementary, and in fact we already know what that is from our work down here. The green there forms a protractor. We know 126 degrees. The whole protractor would be 180. If we take 180 minus 126, we get angle 4, which is going to be 54 degrees. And that 54 degrees can be helpful to help us find angles 3 and angle 6, because, once again, this length here, let me switch colors, this length here and this length here are the same. We just found that angle 4 is 54, so if we take 180 degrees minus 54 degrees, we get 126 degrees. And then we're going to take 126 divided by 2. And when we do that, that gives us 63. So this angle, angle 3, is 63. And angle 6 is 63. And finally, we need to figure out how big angle 7 is. This is a rectangle. So to figure out what angle 7 is, what we know about rectangles is that they have 4 right angles. So here is a right angle, and we know 27 of it. So if we take 90 minus 27, we'll get our angle for 7. 10 minus 7 is 3, 8 minus 2 is 6, and we get 63.